Okay, this presentation covers binary search using recursion. Yesterday we have discussed binary search. However, the implementation is non-recursion. Now, binary implementation of binary search using recursion. First, we will go for what is searching, what is a binary search, what is searching, what is binary search. So, what is searching? What is binary search? Searching is used to determine whether the given number is in the list or not. So, that's we call as searching. There are different types of searching methods: linear search, binary search, Fibonacci search. Like this, there are so many methods are there. So binary search is one of the method to search the given element in a list with less time complexity. So what is binary search? So in binary search, we can search the elements by dividing the list into number of sublists. So it is a recursive method. By recursively, we can divide the list into number of lists and search whether the number is in the list or not. So in this method, the list is repeatedly divided until the element is found or the key element is not in the list. We can divide the list repeatedly until the element is found or not in the list. To perform this binary search, the elements of the array must be in ascending order. Compulsory, it must be in ascending order. Ascending order means increasing order. While in the case of linear search, the elements is in any order. However, in binary search, the elements must be in ascending order. Ascending order means increasing order. What is the procedure we are using in binary search? So let us assume that there are 10 elements. Assign the first position to low, last position to high, and calculate the middle. Middle equal to low plus high by 2. Then we compare the middle element with the key element. When the middle element is equal to the key element, then the number is found. Otherwise, we can modify either low or high. When the key element is greater than the middle element, modify low by middle plus 1. When a key element is less than the middle element, modify high by middle minus 1. So I am repeating, once again I am repeating. First of all, you have to calculate the middle. How we can calculate the middle? Middle equal to low plus high by 2, or top plus bottom by 2, or start plus end by 2. Like this, different names we can use. Once we can calculate the middle, then compare the middle with respect to the key. When the key element and middle element is same, then indicates that the key, then the element is found. When it is not, when the key element is not equal to the middle element, then you can change the either low position or high position. When the key element is greater than the middle element, then modify low by middle plus 1. When the key element is less than the middle element, modify high by middle minus 1. Continue this process until the element is found in the list or the list is empty. So I am repeating in Telugu also. So first ga meer em cheyali ante middle kanukunnam. Middle ela vastundi antunnanu, low plus high by 2. Low plus high by 2 cheste middle vastundi. Ee middle element ni key element to compare. Middle element to కీ ఎలిమెంట్ ఈక్వల్ అయితే అప్పుడు మన ఎలిమెంట్ ఉన్నట్టు లెక్క. ఒకవేళ మిడిల్ ఎలిమెంట్ కీ ఎలిమెంట్ ఈక్వల్ కాకపోతే మిడిల్ ఎలిమెంట్ కీ ఎలిమెంట్ మిడిల్ ఎలిమెంట్ కంటే ఎక్కువ ఉందా లేదా తక్కువ ఉందా చూసుకోండి. కీ ఎలిమెంట్ అనేది మిడిల్ ఎలిమెంట్ కంటే ఎక్కువ ఉంటే మనము హై పొజిషన్ని చేంజ్ చేయాలి. ఏ విధంగా చేంజ్ చేయాలి? మిడిల్ +1తో చేంజ్ చేయాలి. ఒకవేళ మీ కీ పొజిషన్ అనే కీ ఎలిమెంట్ అనేది మిడిల్ కంటే తక్కువ ఉంటే హైని మార్చాలి. హై ఈక్వల్ టు మిడిల్ -1గా మార్చాలి. ఇలా ఎప్పటిదాకా చేయాలి? అంటిల్ ద ఎలిమెంట్ ఈస్ ఫౌండ్. సో ఎప్పటిదాకా చేయాలి అంటున్నాం అంటే ఎలిమెంట్ ఫౌండ్. దీన్నే మనం ఏమంటాం అంటే డివైడ్ అండ్ కాంక్యూర్ సెర్చింగ్ మెథడ్ అంటాం. అంటే లిస్ట్ ని నెంబర్ ఆఫ్ టైమ్స్ డివైడ్ చేస్తున్నాం కాబట్టి సో దిస్ మెథడ్ ఈస్ ఆల్సో కాల్డ్ యాజ్ divide and conquer. So I will take one example. This is one example. Let us assume that there are 10 elements. The key element is 23. So first of all, the list must be so in sorted order. So this is my list. My list is in sorted order. So 2, 5, 8, 12, 16. So 23, 38, 56, 72, 91. All the elements is in sorted order. So I already told that assign the first position to 0. So low, last position to high. So low equal to 0, high equal to 9. H indicates high, L indicates low. Low is 0, high equal to 9. Calculate middle. Middle equal to low plus high by 2. So low value is 0, high enta 9. 0 plus 9, 9. 9 by 2. 9 by 2 is 4.5. You have to take 4 only. So then middle element is 4th position. Then what is the 4th position element? 16. 16 is equal to 23? No. 16 is not equal to 23. That's way. So then we can check it whether the key element 23 is greater than the middle or less than the middle. Here 23, so key is greater than the middle. 23 is greater than 16. That's way change low equal to middle +1. So then middle low, so low value becomes 5. Initially it is 0. Now low becomes middle +1. Middle is 4. 4 plus 1, 5. High is 9. Again calculate middle. Middle equal to low plus high by 2. Low value is 5. High value is 9. 5 plus 9, 14. 14 by 2, 7. Middle is 7. 7th position is middle. So middle equal to key? No. So middle key is greater than middle. Key 23, middle is 56. Key is greater than middle? No. That's way modify high equal to middle -1. High equal to middle is 7. 7 minus 1, 6. Then high equal to 6. So low equal to 5. 5 plus 6, 11. 11 by 2. 11 by 2, 5. So 5th position is 23. Key equal to middle. So the number is found in the list. So check it. So once again I am explaining. The elements in binary search. The elements in the list must be in ascending order. Compulsory the elements in ascending order. So these are the, suppose the list will contains 10 elements. So the initial position is 0 to 9. All the elements 2, 5, 8, 12, 16, 23, 38, 56, 72, 91 all are in ascending order. So we are already discussed that assign the first position to 0, last position to 9. So low equal to 0, high equal to 9. Then calculate middle. Middle equal to low plus high by 2. 0 plus 9, 9. 9 by 2, 4. M equal to 4 middle. 4th element, the value of 4th middle element is 16. So both are equal, key equal to middle? No. Then check it. So whether it is greater than or less than. Key is greater than middle. So key is 26, middle is 16. 26 is 23 is greater than 16. Then so modify low equal to middle +1. Then low becomes middle value is 4. 4 plus 1, 5. Now high is 9. 5 plus 9 is 14. 14 by 2, 7. So middle equal to key, middle is 26, key equal to 23. Both are not equal. That's why again it is check it whether it is greater than or less than. So 23 is greater than 56? No. No, that's way. So we go for so 23 is less than, not greater than. Here there is a mistake. 23 is less than 56. So then, say again we will calculate. So middle equal to high equal to middle minus 1. Middle equal to 26 to 7. 7 minus 1 6. Again calculate middle plus 5 plus 1. 5 plus 6 6. 11. 11 by 2 5. So 5 fifth element is 23. This is the way to calculate. This is the example to determine the element is in the list or not. So I am explaining in Telugu also. First గా మీరు ఏం చేయాలి అంటే ఏరియాలో ఉన్న ఎలిమెంట్స్ అన్ని కూడా కంపల్సరిగా సార్టెడ్ ఆర్డర్ లోనే ఇవ్వాలి. ఫస్ట్ పొజిషన్ ని 0కి అసైన్ చేయండి, లాస్ట్ పొజిషన్ ని హైకి అసైన్ చేయండి. ఫస్ట్ పొజిషన్ అంతా 0, అందుకని లో 0. లాస్ట్ పొజిషన్ అంతా 9 హైకి అసైన్ చేయండి. మిడిల్ కనుక్కోండి. మిడిల్ ఎలా వస్తుంది? లో ప్లస్ హై బై 2. 0 ప్లస్ 9 ఎంత? 9. 9 బై 2 ఎంత? 4. సో ఫోర్త్ పొజిషన్ లో మిడిల్ ఉంది. రెండు ఈక్వల్ అంటే కాదు, ఈక్వల్ కాదు. కాబట్టి ఎక్కువ ఉందా లేదా తక్కువ ఉందా చూసుకోండి. కీ వాల్యూ అనేది మిడిల్ వాల్యూ కంటే ఎక్కువ ఉంది. కీ వాల్యూ 23, మిడిల్ వాల్యూ 16. 23 అనేది 16 కంటే ఎక్కువ ఉంది. ఎక్కువ ఉంటే మీరు ఏం చేయాలి అంటే లో వాల్యూను మార్చాలి. లో వాల్యూ ఏ విధంగా మార్చాలి? లో ఈక్వల్ టు మిడిల్ ప్లస్ 1. సో మిడిల్ వాల్యూ 4. 4 ప్లస్ 1 5. సో దెన్ లో ఈజ్ 5 అండ్ హై ఈజ్ 9. అగైన్ క్యాలిక్యులేట్ మిడిల్. సో 5 ప్లస్ 9 7. 5 ప్లస్ 9 14. 14 by 2 7. Both are equal? No. That's why again it is check it whether it is greater than less than. So 23 is greater than 15? No. No, that's way. So modify high. High equal to middle minus 1. Middle minus 1 means so middle is 7. 7 minus 1 6. Again 5 plus 6 11. 11 by 2 5. So fifth element is 23. Key is 23. Yes, both are equal. That's why the number is in the list. This is the way to determine the given number is in the list or not. This is an example for binary search. So what is the time complexity? Order of login. This is the time complexity of binary search is order of login. So first you have to understand the example very clearly. Once you can understand the example, we can write the program very simple. So the input must be in ascending order. Assign first position to 0, last position to n-1. This is basic requirements. Calculate middle. Middle equal to low plus high by 2. Then compare middle with key. When both are equal, then the number is found in the list. When both are not equal, then check it whether key is greater than the middle or less than the middle. If key is greater than the middle, then modify low equal to middle plus 1. Otherwise, modify high equal to middle minus 1. This is the procedure. So this is the methodology. So then we go for program how to write. So now we are using binary search using recursion. So non-recursion, no. So using recursion. We already know what is recursion. A function which calls the function itself is called as recursion. A function which calls the function itself is called as recursion. ఒక ఫంక్షన్ లోపల అదే ఫంక్షన్ ని కాల్ చేస్తే దాన్ని మనం ఏమంటామంటున్నాను? రికర్షన్. A recursive function must have a condition to terminate from the programming execution. In order to terminate from programming execution, the recursive function must have a condition. Must have condition. That means you must write an if statement to terminate from the programming execution. Then we go for how to implement binary search using recursion. Using recursion. So my screen is visible, Amma? Is my screen is visible or not? Can you chart? Please chat any one person. whether the screen is visible or not. Okay, nice. This is the turbo screen edition. Screen is paused. Please wait. So this is the program. Now binary search using recursion. This is the method. So first we have to write the header files. What are the header files required? So whenever we are using input-output statements, the program must contains so iostream.h, input-output stream.h. We must require the header file hash include iostream.h. This is the header file required for input-output. Then you have to write hash include conio.h for to clear the screens. It's not mandatory. So here I am using CLR. That's why I am written conio.h. So the program must have, so I will write the program by using recursive function. So whenever we are using the functions, the function should have a function prototype because I'm using binary, so top-down programming approach. So the in this the return type of the function, binary search an array int int int. So this will called as a function prototype. What is function prototype? A function prototype will instruct the compiler the name of the function we are using, the return type of the function, the number of parameters, and the data types of the parameters. This line will instruct the compiler the name of the function is binary search, the return type of the function is an integer. This function has 4 parameters. The first parameter is in an integer array, and the remaining 3 are the integer simple variables. This is the about function prototype. Then I will write main function first. Void main int a of 10 or 20 I n found comma key. These are the variables required so far. First, you have to enter the number of values for the array. How many values do you want to enter? Suppose I want to enter 5 values, n value is 5. I want to enter 7 values, the n value is 7. I want to enter 10 values, the n value is 10. So first you have to read value of n. How many values to be entered? CLR is CR. How many values to be? Cout. Enter number of values of the array. Cout. Enter number of values of the array. Cout, not C count. Cout. Enter number of values of the array. How many values do you enter? C in n. If n value is 5, so you have to enter 5 values. If n value is 6, you have to enter 6 values. If n value is 10, you have to enter 10 values. So the n values must be in ascending order. So cout enter n numbers in ascending order. How to enter n numbers? You have to enter n numbers in ascending order. So read n numbers for I equal to 0, I less than n, I plus. Seen yeah. So I entered n numbers in array. First, this is the input. So you have to enter n numbers into the array. So first you have to read n value. After that you have to enter n integers into the array. After entering n integers into the array, then you have to enter the key element. So cout enter key element. Key element means searching element. C in key. So C in key. So I read the key element also. Then we have to check whether the element is in the list or not. So for this, to perform this operation, I use the function binarysearch and assign the result of the function to the variable found. So found equal to binarysearch a comma 0 comma n minus 1 comma key. So I call the function binarysearch. So the result of this function is assigned to the variable. So the result of this function will be assigned to the variable found. If found equal to 1, cout found equal to 1, cout element is found. Else cout is not found. You have to check it whether the element is in the list or not. This is the main function for binary search. This is the main function for binary search. So first in binary search, I read n values. After reading 5 n values, 569. అరే నేను చెప్పే చూడరా నువ్వు ఏం చేస్తున్నావు 569 నేను చెప్పే చూడు నువ్వేం చేస్తున్నావు నేను చెప్పే చూడట్లా ఏడో సినిమా చూస్తుందో నాకు వీడియో కానొస్తుంది నీ వీడియో సో ఫస్ట్ n values read చేయండి so you have to read n numbers after reading n numbers you have to go for binary search so key element of this then I will write the function return type of the function is int binary search int a of 20 comma low comma int high int. This is the function definition. So a is assigned to a, 0 assigned to low, n minus 1 is assigned to not n minus 2. So n minus 1. So there are 10 elements. The last position is 9. That's why n minus 1 is assigned to high and the key element is assigned to key. This is the assignment. So the variables which appears in the function call, those variables are called as actual parameters. Here the highlighted values are the actual parameters. Here these parameters are called as formal parameters. So actually there must be an actual and formal parameters. However, the names cannot be same. There must be an equal number of actual parameters. There are 4 actual parameters and 4 formal parameters. data types of the actual and formal parameters must be matched. So there are 4. Here is also 4. Data types also matched. So then we go for check it. So first you have to calculate middle. So int middle. So I'll call it. First you have to calculate the middle position. How we will calculate middle? Middle equal to low plus high, low plus high by 2. This is the way to calculate the middle. So not sorry. So it is a recursion. No, I'm writing loop. Sorry. So we are using a recursive function. So in recursion, so you must contain a recursive function must have a condition. If low, if low less than or equal to high, yes. If low less than or equal to high, yes. Then so we have to check it. If low less than or equal to high, if A of low, A of middle, if A of middle is equal to key, if A of middle equal to key, return 1. If A of middle equal to key, return 1. Else, if not. So if A of middle is not equal to key, if A first time you have to calculate the middle equal to low plus high by 2. Check it. If low less than or equal to high, then only we can perform all. If not, otherwise you can't. So if A of middle equal to key, so return 1 indicates that the element is found. If not, then you have to check it whether the key is greater than the middle or key is less than or equal to middle. If key is greater than A of middle, if key is greater than A of middle, so if the key is greater than middle, modify low by middle plus 1. So then the value of low is middle plus 1. But I used recursive function. What is recursion? A function which calls the function itself. Here the function name is binary search. Binary search A comma. So middle plus 1. So this middle plus 1 is assigned to low, comma, high, comma, key. Else, if key is so otherwise we can again we'll call it again, no need to call binary search A comma low comma middle minus 1 middle minus 1 comma key. Else, this is the way to implement binary search using recursion. So this is the method. So first of all, you have to calculate the middle. So we will calculate the middle. Middle equal to low plus high by 2. So this is the way middle. After calculate the middle, check whether the middle is equal to key or not. So I am using recursion. So in recursive function, so a function which calls the function itself is called as recursion. So whenever we are using recursion, the function must have a condition, if condition, not loops. There is no looping. That's way. So I will check it. If it's always low is less than or equal to high, if low is less than or equal to high, then we check it. So if a of middle equal to key, if middle equal to key, return 1. Else, if key is greater than middle, if key is greater than middle, so binary search, I will call the binary search. So binary search. So recursion is a recursive function. That's why if the function name is recursion, again we'll call the recursion binary search a comma. So if key is greater than middle, the low value is modified. That's why low is the second parameter. The second parameter is middle plus 1. Then middle plus 1 is assigned to low. High is same and key is also same. Else, if key is not greater than middle, so that means key is less than middle. If key is less than middle, how to modify high by middle minus 1? High is the third parameter. That's why third parameter is middle minus 1. A, low, middle minus 1. Else, if no, if low is less than or equal to high, if not, then return 0. So this is the way. Then I will save the program. There are 4 parameters and then here it is and then and 3, 27, 30, 35, 27. So okay, so there is no enter the number of values of the array. Suppose 5. The 5 values must be in ascending order 1, 2, 3, 4, 5. Then enter the searching element 4. Yes, 4 is found in the list. So this is the way. So all the elements must be in ascending order. I'll go for another example. So sorry. I will show it. I will show. Please wait, I will show it. Okay. So such this is the method. Alt F9. Not saved. NL. Again, there is a problem. Low equal to middle plus 1 I by 2. Then I'll go for compilation and execution. So this is 5 statements. 5, 1, 2, 3, 4. Enter key element. Key element is 2. Yes, 2 is found in the list. I'll go for one more example. So this is the problem. So this is the way to implement them. So remaining program will be told tomorrow. Actually, there is a problem of turbo C. I think turbo C is closing for each time. That's the problem. So I will continue the class tomorrow. Please leave today.